Very good afternoon. This is about microprocessor laboratory. We have a simple experiment to do the arithmetic operation using 8086 microprocessor. So we know that it is a 16-bit processor. As a beginning to learn the basics of 8086. It has a 40-pin IC, 16-bit microprocessor, can handle the data in terms of 16-bit input and 16-bit output we can provide. Although we can give 8-bit data also as input, and we can get 8-bit output also. So to start with 8086 microprocessor, we'll have a simple, very simple exercise for dealing with the arithmetic operation. The first after studying the instruction set only, we are doing the lab. So first instruction is move CX, 000H. So this is for initializing the counter. Then we have the 16-bit register AX and BX. AX is 16-bit register A accumulator also. We are first moving the data 16-bit in the location of 1200, moving to the register AX. To register AX, first a lower bit will be moved and then higher bit. So similarly, register BX, we are loading the 16-bit data, second input 1202. So register BX, we are loading the second input. First we are loading the LSB and then we are loading the MSB. 1 to 1200 we have the LSB of first input, and MSB of first input is again loaded. And 1202 we have the LSB of second input, and 1203 we have the MSB of second input. So add AX, BX, will add both the registers, store the result. Then we are after adding it, if you have a no carry, then we are repeating the operation. If you have a carry, then we need to increase the counter to restore the result as carry equal to 1. First we are storing the carry, which is in CX register, to location 1206. Then we are the added result will be in AX. So AX, BX. Add AX, BX will do the addition of AX plus BX and store the result in AX itself. So that AX is stored into the location 1204. Then termination of the program. So this is what the program, and we'll come to the kit operation. So this is 8086 microprocessor kit. We are just turning it on. While turning it on, we have a display like this, micro 8086. First step is we type the letter A and put enter. It asks for the starting address. You can give the starting address from 1000. For example, if we give the starting address as 4100, we go to that address. So we'll start typing the instruction. First one is move CX, move CX, triple, that is 4 zeros H. So we'll get the so invalid space is there, means it will come to this. We'll type a letter A first. It will ask for starting address 4100. Put enter. We'll go to that location. So first instruction is move CX, 4 zeros. So first data is initializing the counter. So it show the opcode equivalent to that. Then we are putting enter. Then second instruction is move space AX, square bracket 1200. 1200. We close the bracket. It will display the opcode, equivalent opcode. And third line is similarly we need to go up to the last line. First initializing the counter, then getting the input. The third one is getting the second input. So move bx comma square bracket 1202. So close the bracket, then put enter, store the opcode. Then next line is add. So we give given the first input as 06, then put enter. The second higher byte as 0, let that be. And then for the second input, again giving the lower byte as 04. The higher byte I can keep it as 00 for a simple example. And then need to put reset. That is after entering the codes, after entering the instructions, we are given the input, then resetting it. Then go to the execution stage. So go to starting address. So go to starting address of the program. We'll get like this executing. So then you put reset. System will reset. Final step is to verify the output. So substitute byte, the output address 1204, the data will be there, 4 and 5 data will be there, and 0, 6 and 7 carry will be there. So substitute byte 1204. If you are entering it, you get the 6 plus 4. If you are adding it, the result we get is 0A. Since lower byte alone is being added, the carry is 0. Carry is 0, 0. So 1206 and 07 are showing the carry. 1204 and 5 shows the result. So this is what the simple example of arithmetic operation. Arithmetic operation using the 8086 microprocessor kit. Thank you.